Hi! Today we're going to go over some examples of evaluating expressions given numeric values for the variables. So this is an example of one you might come across. Evaluate each expression if a equals 1, b equals -3, and c equals 5. And for our first example, we have the expression a plus 4b. So what we're going to need to do here is use the substitution property, which tells us when two things are equal, we can substitute one for the other. So in this case, because a is equal to 1, anytime we see an a, we can write a 1 instead. Anytime, since b is equal to -3, anytime we see a b, we can write a -3 instead. One technique that is helpful when you're doing this is to highlight the different variables in different colors. So I know every time I see a b, it's going to end up being a -3, so I'm going to highlight the b's as in yellow. And every time I see an a, it's going to be 1, so I'm going to highlight that in blue. When we substitute values into the expression, one really important thing to remember is to put those values in parentheses. So we don't just substitute in 1, we do parentheses and 1. The analogy that I like to make for this is that when Amazon delivers you a pair of shoes, it doesn't just send you the shoes, it puts them in a box first before it delivers it to your door. You'd be pretty mad if your shoes just came all crazy right out of a box when they were delivered. And it's the same thing here. It's really important to put your numbers into parentheses before you substitute them in. We want them delivered in a nice little box. Okay, so we substituted 1 for a. We're going to keep the plus 4 the same. And then in parentheses, we're going to put -3 for b. Okay, so now that those things have been substituted, we're going to use order of operations to evaluate the expression. So we have 1 plus 4 times -3. So using our order of operations, we need to do this multiplication before we do the addition. So we're going to keep 1. You can actually take it out of parentheses at this point because the parentheses aren't changing anything for us here. And here we have the problem 4 times -3. 4 times -3 gives us -12. We'll keep that in parentheses because of the negative. We never want two operations in a row without a parentheses sign. And then 1 plus -12 gives us -11. And that would be our answer. So that was a pretty simple example. Now we're going to try one that is a little more complex. So for our second example, we're going to use this expression. 3c times the quantity a minus b squared plus the quantity c minus a squared. Okay, just like before, I would highly recommend highlighting. So we've got an a here and an a here. We've got a b here. And then for c, I'm going to do both and make a green highlight because I don't have a third highlighter with me right here. So here we go. Make those c's green. So you really need a third color. Okay. So now we're going to go ahead and substitute all those values in the appropriate places. So 3, and put them in parentheses. So 3 times c would become 3 times 5 in parentheses. Then you have the parentheses here. 1 minus -3 squared and parentheses plus parentheses, and then we have 5 minus 1, and then we keep that squared. And I'm going to go ahead and highlight what we substituted in because you'll notice wherever we had an a, now we have a 1. Wherever we had a b, now we had a -3. And wherever we had a c, now we have a 5. So everything looks the same, except in place of the letters, we put the correct corresponding numbers. Okay, now we are going to need to use order of operations again. We've got quite a bit going on here, so just to remind you of your order of operations, I like to use GEMMA. So we've got grouping symbols, exponents or roots, multiplication or division, addition or subtraction. So grouping symbols, we've got parentheses here and here. And when we talk about grouping symbols, we want to look for symbols where there is more than one thing inside the parentheses. So we have parentheses around 5, but there's only one number inside. So that doesn't really count as a grouping symbol because it's not grouping multiple things together. Okay, so we are going to leave this 3 times 5 alone, and we're going to look inside this first set of parentheses. And within each set of grouping symbols, we need to go through the whole GEMMA process again. So inside we see here, we don't have any other grouping symbols that are mattering because again, they only have one number inside of them, so they're not grouping different things. But we do have an exponent, so we need to evaluate that first. So 1 minus, okay, so negative 3 squared is the same thing as saying negative 3 times negative 3, and negative 3 times negative 3 is positive 9. So negative 3 squared evaluates to positive 9. Okay, and we can look inside our second pair of grouping symbols since it's separated by a plus. And in our second set of grouping symbols, we have 5 minus 1. So we could evaluate that to 4. All right, on our next line, we still have parentheses over here that we need to finish evaluating inside of. So we're going to keep that 3, keep that 5. 1 minus 9 gives us negative 8. And then we still have this 4 squared. Okay, so here we've got multiplication, multiplication, addition, and an exponent. If we're following the steps of GEMMA, that means that we need to evaluate the exponent next. So we're going to keep 3 times 5 times negative 8 plus, and 4 squared is 16. And then in our next step, now we just have multiplication and addition. So we're going to do the multiplication next from left to right. So 3 times 5 would give us 15. We have 15 times negative 8 plus 16. Okay, 15 times negative 8. Well, 15 times 2 is 30, which means 15 times 4 is 60. So that means 15 times 8 is twice that, 120. And because we had a negative here, this would be a negative 120 plus 16. And then evaluating that, we've got a negative plus a positive, but the negative is bigger. This is going to end up being negative 104. So hopefully that helped with evaluating expressions if you're given values for the variables.